So let's solve another problem. You have a light rope is attached to a block with mass 4 kilograms that rests on a frictionless horizontal surface. The horizontal rope passes over a frictionless massless pulley and a block with mass m is suspended from the other end. When the blocks are released, the tension in the rope is 10 newtons. You are asked to draw free body diagrams, one for the 4 kilograms block and one for the block with mass m. Letter B, what is the acceleration of either block? And letter C, find the mass m of the hanging block. So let us start. Again, the first thing that we need to do in solving problems is to draw your diagram. So we need not draw your figure because it's already given in the problem, and this is the figure right here. Now the second step is to identify the given parameters and then the required. So let's write the given. So based from the problem, the mass of the block on the surface is 4 kilograms. So let's write 4 kilograms right here. And then it rests on a frictionless surface. That means that your friction force here is equivalent to 0. You also have a rope that is frictionless and massless pulley. So therefore, we will not be considering this pulley right here. And then the mass of your block is m. Okay, so the tension in the rope is 10 newtons. Okay, so let's write tension of the rope, that is 10 newtons. Okay, so we are now done identifying the given, and then we are required of the free body diagram, we are required of the acceleration, and we are required of your mass. Okay, so let's now proceed to the next step, which is to draw your free body diagram. Now for problems with two separate objects, what you need to do is to draw them separately. So I'm gonna draw first block A, and then I'm gonna draw block B. Okay. So after separating the two objects, so this has a rope, let us now identify the forces involved in each object. So again, since this one is on a surface, therefore it will automatically have the following forces. The first one is your mass. So block A will have its mass, and again, mass is drawn perpendicular to the ground. So if you will be continuing this problem, so since it's horizontal, your surface will also be parallel with your ground. So if this is the foot of the surface, so here is your ground, and this is your surface. So again, weight is perpendicular to the ground, so this is how you will be drawing your weight. Okay, so the next one is you will have a normal force. Normal force is always upward perpendicular to the surface. So if this is the surface, this is 90 degrees, so this is your normal force. The next one is friction. Again, friction is having the direction opposite your motion, and it is always parallel to the surface. So parallel to the surface, and then if the direction of the block is moving to the right, so this is the direction of your block, therefore your friction force is moving to the left. But again, please take note that this has a value of 0. Okay, so and then the last one, since you have a rope right here, you will have another force which we call your tension force. And tension force is always drawn away from your object, moving away from your object. So it will, and it's with the direction of your rope. So since the rope is going to the right, so you will have a pulling force going to the right. Okay, so now we're done. Let's now proceed with block B. So for block B, again, you have your rope right here. Therefore, you will have tension force. And since it's a pulling force, then the direction of your tension is away from your box. Okay? And then, you have no friction and you have no normal force because you do not have any surface there. It's hanging. So, therefore, what you will have now is a weight. All objects will again have weight. Okay? We can solve for the weight of block A, but we cannot solve for the weight of block B. So, for the weight of block A, you have mass times acceleration due to gravity. So, your mass is 4 kilograms. So, 4 times 9.8. Therefore, you have 39.2 newtons. Okay? So, yeah. Then, let us now draw this one as your free body diagram. So, for block A, again, let's draw your coordinate system. Okay? So, you will now have your tension force. We did not label it as T. So, you have tension. Okay. Then, you have normal force. Then, you have friction. And then, you have your weight. The angle of tension is 0. 0. Your normal force is 90 degrees. Your friction is 180 degrees. Your weight is 270 degrees. Okay. Now, for your block B, let's just again draw it. Okay. Now, here's the key thing that you have to remember when you have a situation such as a hanging object. Now, for your hanging object, your coordinate system should always be in line with the motion. And since this block will be moving downward, okay, so this one will be moving downward, therefore, your coordinate system should be reversed because this one is going downward. So, instead of having your coordinate system as 0 here going to 90, what we will have is 0 counter. We will be going clockwise. Okay, so the reason is because we have to consider this direction, that those going downward is positive. But if the motion is opposite, for example, you will be pulling this block right here to the left, therefore the motion of this box will be moving up, therefore the direction of your free body diagram for this hanging object will be counterclockwise. So 0, 90, 180, and then 270. But since this is moving downward, opposite siya. Okay, so you have 180, then 270. Let us now proceed. So we will now draw. You will have your weight. Then you will have your tension. So tension is angle 270 degrees and then weight is angle 90 degrees. Okay, so we're done with your free body diagram. You have already answered letter A. Let's now proceed with letter B. Okay, so for letter B, we are asked to find the acceleration of either block. Now, there are two things that you need to remember for a connected object. Number one is that the acceleration in block A is always equivalent to the acceleration of block B. That is because they are both connected by a cord. So, therefore, they will be moving the same manner and they will be moving at the same rate. Okay, please also take note that it is not equivalent to your G. We have talked about in our previous chapter that when you have a falling object, you will have an acceleration due to gravity or this G. But please take note that it is only applicable for a free fall, meaning no other forces is being considered. But in this problem, this will not undergo free fall because, as you can see, this is connected to a box. So this will have its own acceleration. The second thing that you have to remember is that the tension in this box is also equivalent to the tension on box A. So the tension in box A is also equivalent to tension in block B. Because, again, you only have the same rope. And it is said here that you have a frictionless and massless pulley. So the pulley will not do anything to lessen the tension. So this tension A and tension B are equivalent. So we can simply call them T, and we can simply call your acceleration as A. Okay? So that's it. You may now proceed to the solution. So for the solution, we can now solve. We can now solve by calculating first the components. So let's have Tx, then Ty. So you have T cosine 0, T sine 0. You have N, X, and Y. So N cosine 90, N sine 90. So we will no longer consider friction because friction is equivalent to 0 from the word frictionless. Okay, you also have Wx and then Wy. So W, or weight of the block A, is 39.2. 39.2 cosine 270, then 39.2 sine 270. So using your calculator, you will now have T 0, 0, N. Then you will have 0 and then negative 39.2 newtons. Okay, let's proceed to the other block, which is block B. So you have Tx, Ty. So T cosine 270 and then T sine 270. So we have 0 and then negative T. So we don't know yet the weight of your block B. So let's just identify it as Wx and then Wy. So Wx, we have W cosine 90, then W sine 90, or weight cosine 90 and weight sine 90. So you will have 0 and then your weight, whatever the value of that weight. Okay, so let's now, we have now the components. Let's proceed to equating your forces. Okay, but first, going back to the problem, we have to identify which law is applicable in this diagram or in this problem. So looking at the problem, as you can see, you will have an acceleration because you will be having a tension and then the force of each other. So you have here, what is the acceleration? So since we are asked for the acceleration, obviously this is under the Newton's second law. So this is second law. Okay, so in order to solve this one, let's first consider block A. So for A, you will have summation of forces X is equivalent to MA. Now please take note that your summation of forces X here is equivalent to MA, but your summation of forces Y will be equivalent to 0. Why? Because if you will be observing this box, your block A, the motion is only going to the right. You will not have a motion going up or going down. So therefore, you will have no motion at Y, or simply it is at rest at Y. So your summation of forces Y is 0. Okay, second law only for summation of forces X. Okay, now let's have this one. So you have summation of forces X. So you have Tx plus Nx plus Wx is equivalent to mass times acceleration. So Tx is T, Nx is 0, Wx is 0. Now the mass of the object is 4, and then the acceleration is A. So simplifying, you will have T is equivalent to 4A. Okay, let's now proceed to summation of forces Y. So summation of forces Y, you have Ty plus Ny plus Wy equals 0. So Ty is 0, Ny is N, minus 39.2 equals 0. Normal force is 39.2 newtons. Okay, so solving for acceleration, we are given the value of T, which is 10 Newton. So it said it was stated in the problem. So you have 10 is equivalent to 4A. Therefore, your acceleration is equivalent to 10 divided by 4, or that is 2.5. 2.5 meter per second squared. So we were able to answer question letter B. Now let us now answer letter C. Now for letter C, we will be using your block B. So for block B, we have this FBD here. So TX and then TY, then WX and WY. Now please take note that the motion of block B is only at your y-axis, no horizontal motion. So therefore, your summation of forces X is equivalent to 0 for your block B, but your summation of forces Y is equivalent to MA, because again, you have no motion at X. Okay, so you have now TY and then WY. So TY plus WY is equivalent to MA. So TY is negative T, and then your WY is W. So negative T plus W equals MA. So again, I'm sorry, you have here negative 10. The value of TY is T, and your T is equivalent to 10. So you have here negative 10 plus W equals MA. So your acceleration is 2.5 based from our problem or on our solution earlier. So 2.5. Now your weight is usually solved as mass times acceleration due to gravity. So we can substitute negative 10 plus m times 9.8 equals m times 2.5. Now solving for the mass, you will have negative 10 plus 9.8. I will let your m equal to x. Alpha equals 2.5 alpha x. Then shift. So our mass is 1.3698, or that is 1.37. 1.37 kilograms. That's it. Therefore, summarizing your answer, your acceleration is 2.5 meter per second squared, and mass is equivalent to 1.37 kilograms.